I'm going to say, note, we have something called a difference of squares. A difference of squares is when both of these binomials look exactly the same. So you have two binomials that look exactly the same. The only difference is one will have a positive and one will have a negative. And it doesn't matter where the negative or positive are. So you could have a positive then a negative, or you could have a negative then a positive. Doesn't matter as long as they look identical, except for a positive and negative in between. You can just go ahead and write this as a squared minus b squared. That's known as a difference of squares. Bless you. So if you recognize that on this one, that we have cosine 1, we just have a plus or minus in between, you could have easily just turned this into cosine squared alpha minus 1 squared. But what happens when you have 1 squared? Don't tell me it's 2. It's just 1. It sounds funny, but a lot of us are going to make that. It just happens. It just happens. You see 1 squared equals 2. Doesn't mean you don't know it. Just means at that instance you made a little mistake. So rather than putting 1 squared, sometimes we just put 1. I'm going to leave it as 1. I don't care how you put it. Just realize that that is, in fact, 1. That is cosine squared minus 1. All right, now if I was doing, let me erase that so I don't erase the 1. There we go. All right, so we have cosine squared minus 1. Now, here's my advice to you. Now is not a time to go to that small identity sheet and find one of those variations that matches this. We need to get in the practice of going, if I have a sine squared and a 1, we need to have this one memorized first and foremost, and that is the fact that sine squared x plus cosine squared x equals 1. And I guess maybe I should replace those with alphas to match kind of the problem we're on. So I'm going to go ahead and I'm going to replace those x's with alpha. Doesn't really matter. They're just variables. Our job is to start getting in the habit of realizing that I can manipulate this equation to match certain circumstances. So the circumstance I want is I want to have a cosine squared and a negative 1 all by itself in this equation. Well, the first thing I'm going to create is this negative 1. So that means I'm going to move this 1 to this side, which is going to look like this. We're going to now have sine squared alpha plus cosine squared alpha. But if I subtract 1 on both sides, I'm now going to have a minus 1 on this side. So now I'm going to note, hey, I got this. I got that, but it's not all by itself, so I need to move this sign to the other side. So to do that, I'm just going to subtract sine squared from both sides. Kind of looks Eastery up there. Those will cancel out, and I'm just going to have a cosine. Wrong color. It's Eastery. Just the colors I kind of picked there. Pastelli. I guess pastelli would be a better. Pastelli. So we're going to have cosine squared alpha minus 1 equals negative sine squared alpha. Now, I'm going to double check. Did my original one have a positive cosine? Yep, both of these are positive cosine squareds. Are they both negative 1s? Yep, they're both negative 1s. That matches it exactly. It has to match exactly. It cannot be just close. It has to be exact. Yeah, Carter.
When you had the negative 1 squared, would that not be...
So it would not be a positive 1. So I think this will answer your question a little bit. So if I have negative 2 squared, that actually equals a negative 4 because we do the 2 squared first and then we have a negative on the outside. That is different than if I do parentheses negative 2 squared. If I have parentheses negative 2 squared, now that is negative 2 times negative 2, which would actually be a positive 4. And we're going to talk more about that later, that parentheses are important today. So if it's in parentheses, negatives become positive because you square them. If it's outside the parentheses, you have to do the square first, and then negative goes along for the ride. So in this case, when I had that negative 1 squared, I did not have parentheses around that negative, so the negative remains, and it just turns into a minus 1. Thank you for asking that, though. All right, so now I see that this matches this cosine squared minus 1. So this whole thing just equals a negative sine squared alpha And that's our end answer, which was A, negative sine squared alpha. So I apologize for having the sine squared alpha up there, which can confuse people. You have to take the time to write it out so it matches exactly. Not close, exactly. Yeah.
Negative sine of parentheses alpha squared also work or no?
Say that one more time.
So, yeah, I can write it.
Yeah,
This.
sure. I set the picture in my head.
Would that also work or no?
Yeah, that would work.
So
But
add it first.
but typically what you'd write to do that is you'd write it like this. You'd put the sine alpha in and square on the out to let yourself know that everything's being squared, because if I get rid of those parentheses, you don't know if the alpha is being squared or the entire thing is being squared.
Oh, yeah, that makes sense.
That is why we put the square on the inside so we don't have to put the parentheses.
I realized it at the end. I just had it like that at first. So.
All right, questions on the bell work? Yeah. Yes. Okay, then what questions do we have from the homework? Oh, yep. One is correct. You need to do what?
One for what?
We'll go through it.
Why wasn't blurred out?
Just to make sure that you guys did it.
Oh, I got one too.
So you're going to see a lot more of them. We're going to have missing work, missing stuff to make sure you're not just copying the answer keys. We've been doing this long enough, and these take practice and not copying. So a lot of times when I check for correctness, I'll actually check that one to make sure you have proper work. Not that it's 100% correct, but you did proper steps and you didn't just go AWOL. All right, so we would change sine x. We'll leave that alone. We change the cosecant to 1 over sine. We leave cosine alone. We change that to being 1 over cosine. With keep change flip, this will turn into sine x times sine x. This will turn into cosine x times cosine x, because it's cosine x over 1, which turns into sine squared plus cosine squared, which would equal 1. Now, where some people might have got 2 is, if I would have flipped these, so if this would have actually been cosecant over sine, I would have had 1 over sine x plus 1 over, so this is if I had the original fractions flipped. That would actually equal 2 with the keep change flip. Actually, it wouldn't. Scratch that. Don't get that out of your mind. There's no way for this one to be 2. You just made a mistake if you put 2.
Oh, bro.
All right, yeah, shh, guys. I don't care about bros. That was Monday. That is an identity that's on your identity sheet. That is the backbone of the Pythagorean identities. That sine squared plus cosine squared equals 1. All right, other questions on homework? Yeah.
Can we do 8 real quick?
Sure. 8, we have 1 plus cosine alpha tangent alpha, cosecant alpha, all over cosecant alpha, right? Now, here's my advice to everyone in here. Do something. Do not get to the test and put nothing down. So what I would do on that one is I would locate the things that aren't cosine or sine first. So here's what I'm doing in my head. I'm writing, okay, this one looks complicated. We have 1 plus cosine alpha, tangent alpha, cosecant alpha, all over cosecant alpha. It looks complicated, but the beginning of this looks the same as any other problem we had there, and that is find things that are not sine or cosine and maybe box them in. Anything that's not in terms of sine or cosine, you must change to sine and cosine. So I'm going to now have 1 plus, well, let's leave cosine alpha alone. Tangent becomes Does tangent become sine over cosine or cosine over sine? Oh, it becomes sine over cosine, because what is it? It's cotangent equals cosine over sine. So this one must be sine alpha over cosine alpha times cosecant is 1 over sine alpha all over 1 over sine alpha. Well, you're going to see a lot of stuff cancels out, Jude, because if I picture this as cosine over 1, and you could write that in if it helps you, that these cosines will actually cancel out. These sines will cancel out. And here's the biggest mistake people are going to make. Whoop. Not just drawing a long line when they shouldn't. They're going to tell me this equals 1 over sine alpha. What mistake did I make? I didn't leave the original 1. Because that 1 never got canceled out. This is 1 over 1, which is 1. So that actually would be 1 plus 1. Good.
Why did you not cancel out the 1 over sine and the numerator and denominator? Like if it was a choice or
See this plus right here? You can't cancel it out if it's trapped by these pluses. Because this is actually, so just as a quick algebraic example of that. So let's say I have 1 plus 2 over 2. I can't just cancel out those 2's because that plus holds it into 2 fractions. It's actually as 1 over 2 plus 2 over 2. That's what's equal. Then you could cancel out. If you broke it apart, you can cancel out. But it either needs to be directly above it or everything has to be attached by multiplication.
So if there was no 1, you could do that?
If there was no 1 there, we could have canceled out the 1 over sine, 1 over sine. But since that 1 is there, held by that plus sign, can't touch it like that. Okay, so now we have 1 plus 1 over sine, which would actually be 2 over 1 over sine, which we can do keep, change, flip to keep the top. Flip the bottom fraction, which would be sine alpha over 1, which would just equal 2 sine alpha. And we're done. So a lot of it is just starting off, right? I think if you would have had these written out, you would have thought of some things you can do. The problem was you just didn't do that first step. We got to do that first step. All right. More questions. Go. Yeah. That's a great question. Other questions?
Yeah.
Going once, going twice. Zold. All right, function values. All right, the first thing we're going to do is we're going to go in our way back machines and go back to geometry class because we can solve this in geometry class. Boo indeed. Why? Geometry's fun. All right. So if I was in a geometry class and someone said, you know what, sine alpha equals 3 over 5 and I'm supposed to find cosine alpha, I would draw a right triangle. I would go, okay, let's draw a right triangle. Because sine, cosine, tangent all come from right triangles. I'll name one of these alpha. Now I have alpha. I have a side that's opposite it. I have a side that's adjacent. And I have a hypotenuse side. Well, if I gave you sine alpha equals 3 over 5, sine from SOHCAHTOA, so says it's opposite over hypotenuse. So we have 3 over 5 where I have this missing side. Well, it turns out if I ask for cosine of alpha, so SOHCAHTOA, ka says adjacent over hypotenuse, so our cosine alpha would actually equal just x over 5. So if I can find that x, I'm good. How do I find that x? I'm going to use the Pythagorean theorem. It's also a Pythagorean triple. If you realize that there's a 3, 4, 5 triangle, that's one way we could do it. But we're going to use the Pythagorean theorem. The Pythagorean theorem is a squared plus b squared equals c squared. In other words, side squared plus side squared equals hypotenuse squared. So in this case, we are going to have 3 squared plus x squared equals 5 squared. Well, 3 squared is 9er. We got an x squared. We have a 5 squared, which is 25. I would subtract 9 from both sides, and we'd have x squared equals a 16. Now I would take the square root of both sides, and now let's not be in geometry for a second. We are now pre-calc students. And when you're in pre-calc and you take the square root of both sides, you must add the plus or minus. So that means our x equals a plus or minus 4. That's a problem. That's a problem because only one of these is correct for the triangle, and it's not always the positive one. You have 2 ways to correct for that. Both stem from this fact. I didn't read it yet, but every one of these problems is going to tell you what quadrant this triangle is in. This triangle is in quadrant 2. So one of the easiest ways to pick out whether it's going to be positive or negative is to look at what they ask for. They're asking for cosine. And if you're asking for cosine in your quadrant 2, we have to remember that saying that all students take calculus. What's positive in quadrant 2? Sine. Sine is positive. What else? There's one more that's positive in quadrant 2. Don't just throw out guesses. Have a valid reason. What else is positive in quadrant 2 besides sine? My hint is they're buddies. Our cosecant. Yep. Our cosecant will also be positive. So that means cosine needs to be negative. So our cosine alpha is going to be a negative 4/5 because we are in quadrant 2. Tells you to use the negative. The other way you can picture it, it makes it a little bit more difficult, is if I'm in quadrant 2 and I draw my triangle in quadrant 2, I have to go left, which means I'd have to go -4. So that's why this is a -4, because you are going left to get to quadrant 2. I have to go left, up, 3/5. The hypotenuse is always positive because it's squared. So those are 2 ways. I'm going to stick with, for this class, the all students take calculus, because that way we don't have to keep drawing all these triangles every single time. Because once again, I said we're no longer in geometry class, we are in pre-calculus. And in pre-calculus, we have 3 Pythagorean identities that allow us to switch between our different trig identities. So now we're not going to draw a triangle. Instead, we're going to say, you know what? If you give me sine, I can use this equation to get to cosine, because this equation has both sine and cosine in it. Kind of like if I had x squared plus y squared equals 2, and I tell you x equals 2, you can use that to get your y value out. So that's the same thing that's happening here, that I know that in this equation, this value right here is actually going to be that -3/5 from above. So because I know sine equals -3/5, I can plug it into this equation. Which, for a second, don't write down what I'm writing. This is the mistake I see all the time. This mistake I see all of the time. This is not solvable. This is not solvable as written, and you're going to be stuck, and you're not going to be able to finish it. You have to realize I did not say alpha equals -3/5. I said the entire sine thing is here. Note what I circled here. I circled it on purpose. I circled everything except for the squared. Everything except for the squared gets replaced with that -3/5. So now you can write down what I'm going to write. I am going to now replace sine x with negative 3 over 5 squared, and I'm going to use parentheses. So I'm going to use parentheses. Do you have these?
Yes.
Okay. So I'm going to go ahead and I'm going to use parentheses. Now, I use parentheses because, like Carter brought up, when you square a negative, it becomes positive. So basically, anytime I throw something in here, it's going to be positive once I square it. Yeah?
Why'd you do negative 3 over 5?
Oh, it's positive 3 over 5, right? Sorry. Is it 3 over 5? I don't want to go back to the slide.
Yeah.
Okay, regular 3 over 5.
I thought I understood.
Nope, you're good. You're good. Would it have mattered, though?
No.
It turns out it wouldn't have mattered whether I put positive or negative. So you could make that mistake and still have it correct. I should write 3 over 5 so it doesn't look confusing. That's the same thing as set up there, 3 over 5. So if I do 3 over 5 squared, remember when you square a fraction, you square the top and the bottom. So that means you're going to have 3 squared, which is 9, over 5 squared, which is 25, plus cosine squared, alpha equals 1. Now, I know I need to solve for cosine, so that means I need to isolate it. To isolate it, I'm going to subtract 9 over 25 from both sides. Now, here's a pro tip so we don't have to rewrite the entire equation. I don't want to write 1 here. What would be an easier way to picture 1 so I can actually do this subtraction?
25 over 25.
I want to rewrite it as 25 over 25 so it has the common denominator. So I'm picturing this is actually 25 over 25. Now remember, when you add or subtract fractions, they need a common denominator, and then you just add or subtract the numerators. So that 9 over 25 cancels out on this side, and I now have cosine squared alpha equals 25 minus 9, which is 16, over 25. I'm actually giving myself a little bit of space so I can put my square root there. So now I need to take the square root of both sides, realizing that when I take the square root, I have 2 possible answers. Either it's positive or it's negative. I'm going to hold off, and I'm going to keep writing the positive and negatives until I'm 100% certain what I want. So now I'm going to have cosine alpha equals a positive or negative square root of 16 over the square root of 25. Which is the same thing as plus or minus. Square root of 16 is 4, square root of 25 is 5. Now, when I box in the answer, I had to decide if it's positive or negative. We already said it's in quadrant 2, where only sine and cosecant are positive, so this is going to be negative 4 over 5. Once again, maybe I'll point to that negative and say, this is because we were in quadrant 2.
How did I know we're in quadrant 2?
Because I stated it in here. I'll straight up tell you. You don't have to guess at it. If you're guessing at what quadrant it is, you missed something. So I will note, on your homework, I might not just say quadrant 2. I might say your angle is between 0 and pi over 2. If you look at that first problem, it says 0 to pi over 2, which is the same thing as quadrant 1. So I'll either tell you straight up what quadrant you're in, or you have to do just a little bit of work to figure out what quadrant you're in. Okay? All right, yes? So if I said, you'd never have to just guess at it. So if you look at your homework on problem number 1, it doesn't say you're in quadrant 1, but it kind of says you're in quadrant 1. It says the angle is between 0 and pi over 2, I believe. And 0 and pi over 2, 0 degrees to pi over 2 is quadrant 1. Or I could say, it's somewhere between 90 degrees and 180, which you'd be, oh, that's quadrant 2.
Okay.
So I'll always give you the information to discover what quadrant it's in. All right, this is the backbone of what we're doing today. We're just going to take a step up from here. The step up from here is, our next problem is almost identical, except for this time I give you tangent alpha equals negative 2 over 3. I'm assuming it's an important text. Hang on, we have an important text. Okay. Yeah, all right. So we have tangent alpha equals negative 2 over 3, but I'm gonna highlight something really quick. Alpha's in quadrant 4. I should probably stop there and say what's positive in quadrant 4. What trig function is positive in quadrant 4? Cosine and? Don't just yell out tangent every single time, I feel like. And secant is correct. Don't just throw out tangent because it's all students take calculus. Every major one, cosine, tangent, and sine, all have their own quadrants where they're positive in. They have to worry about their reciprocals. So many times I just hear people yell out tangent for every single one of these. That's not true. It's got its own quadrant 3. All students take calculus. Tangent is positive in quadrant 3, so cotangent is. All right, so we have cosine and secant are positive.
I'm just confused where you got that from. I don't know.
Where I got that positive from?
Cosine and secant.
I got it from all students take calculus. Yep. All right, so we have cosine and secant are positive because we're in quadrant 4. All right, then it says we're supposed to find all the other trig functions. That means I need sine, cosine, secant, cosecant, and cotangent. Those are the other 5. It sounds like a lot, but a lot of them, you really are just finding 2. Because everything works with reciprocals. I.e., if I know that tangent alpha equals negative 2 over 3, the very first thing I'm going to find is cotangent. Because cotangent and tangent are reciprocal. So the very first thing I'm going to do is I'm going to say, you know what? If tangent is negative 2 over 3, that means that cotangent of that same angle is negative 3 over 2. And you don't have to worry about positives or negatives. You just flip the two numbers. And that is 1 out of 5 done. I just need 4 more. And I'm going to show you we only need 2 more. Because everything else is reciprocals. If I know sine, I flip it, I have cosecant. If I know cosine, I flip it, and I have secant. If I have secant, I flip it, and I have cosine. So now, here's the thing. I know tangent, and I know cotangent. That means I need to dig deep into my Pythagorean identities and find ones that have tangent and cotangent, because sine and cosine aren't going to cut it, because I don't know either one of those. So my hint is, well, if they give me tangent, find a Pythagorean identity that has tangent in it. Is there one that has tangent in it? And there better be, because there's one that has every single trig function in it. Yep. Which one says tangent in it?
1 plus tangent squared equals secant squared x.
Equals secant. I'm just replacing it with alphas. You can replace it with x's if you want to. I'm just going to leave it with the alphas that they gave me. All right. This will get me, if I know tangent, it'll get me secant. If I know secant, it'll get me tangent. So whatever one you know, it will get you the other one. So I know that tangent is negative 2 over 3. So I'm going to replace this entire tangent alpha with that negative 2 over 3. So we have 1 plus negative 2 over 3. Don't write too big because we have a little bit of work to do. That's really all the pre-calculus you need to know. The rest is algebra. So the first thing I'm going to do is I'm going to make sure I have parentheses. So I know that when I square it, I will have a positive value. And here's a little pro tip. I'm going to do the 2 over 3 squared first before I attach the 1. So negative 2 squared is a positive 4 over 9 equals secant squared alpha. Now the reason why I skipped 1 is because all of these times we're dealing with the 1. We need to change it so I can rapidly add these or subtract these. So instead of 1, I'm going to replace 1 with 9 over 9. It's still 1, but I can now do that addition really quick. So now we have a common denominator of 9, which means we just add our numerators. So we're going to have 13 over 9 equals secant squared alpha. I will take the square root of both sides, making sure I attach a positive or negative. And it might be a good time to go, okay, I know I can't give 2 answers. So maybe now, rather than having to write plus or minus over and over and over, maybe I make a decision. What am I going to pick for this one? Is it going to be positive or is it going to be negative? It's going to be positive, because that's why I put up here that secant. If I see secant, I'm going to put a positive there. So right now I can just go ahead and say, I'm going to pick the positive right now. I'm going to pick the positive because we are in quadrant 4. And quadrant 4 is all students take calculus, cosine positive, secant positive. All right, I'm also going to switch the sign of the secant real quick. So I'll have secant alpha equals a positive. Square root of 13, that's an ugly number, right? So I probably won't simplify that. We'll just leave that as square root of 13. Square root of 9, that's 3.
You have to put the positive.
You do not have to put positive. I put it for my notes just so I know I picked something. All right, now that I know secant, I also know cosine. So cosine alpha is going to equal, just flip it, it's 3 over square root of 13. I should simplify this. I'm going to talk about that in just a second. So if I multiply the top and bottom by square root of 13, I come up with 3 square root of 13 over 13. On a test, I'm not really worried about you. There's enough going on here. If you don't simplify this, you're going to be okay. The only problem is if you don't simplify, it won't match my answer key. So you might have to simplify for the homework so you can check the answer key. But if you were on a test or something like that, you didn't simplify this, I'll just put a little note that says you should probably simplify this, but I understand because you got enough going on. Just get it right. Don't worry about simplifying, just get it right. All right, now we have to use one more identity. So I now have cotangent, tangent, I have secant, and I have cosine. I need one more identity. I need sine. Is there a Pythagorean identity that has sine in it?
Yes.
Yes, we have sine squared plus cosine squared equals 1. I'm not writing it. Don't write it. You can if you want to. You can use that one, but I'm not going to. And I'll tell you why. So if I had sine squared plus cosine squared equals 1, so don't write this. I'm just hypothetically doing this. I'm going to pick a different way, and I'll tell you why. Do I know what cosine equals?
Yes.
So I could use this method. I just take that, plug it in for cosine, square it, and do all that work. Now, the reason I'm not going to do that is going to be twofold. I'm in fact going to do 1 plus cotangent squared alpha equals cosecant squared alpha. Because cosecant will get me to sine. Can you think of a reason why I might choose this method versus the sine squared plus cosine squared, even though I said it would work? Michael?
Cotangent is like smaller numbers.
Cotangent, that's one reason. Look at cosine. Cosine has that wicked thing happening here, where this one I can just have negative 3 over 2. It's going to be easy to square. I know it's going to be easy to work with. There's one more reason why I picked this one. Yeah.
You also get the cosine identity.
You have cotangent.
I have cotangent, not cosine.
Oh.
Yeah. I'm just using this to get sine.
Flipping cotangent play easier than solving that.
Yeah, what Charlie said. What's easier, flipping a fraction or going through all of this work? Flipping a fraction. So I am more likely to have this correct than I do have this one correct. And so what I'm thinking is, if this is wrong and I plug this in, I have everything wrong. Where if I could flip a fraction and plug that in, I'm more likely to have started with a more correct answer than the other one. So that's why I picked the cotangent squared versus the sine squared plus cosine squared. But does it make sense why you could use either one of them? Okay. So notice in the answer key, I may have gone a different version than you did. I may have gone this way, or I might have did sine squared plus cosine squared. Your job is to check to make sure your answers are correct. Both methods will work. All right. So I'm going to move forward in this and say this is 1 plus, our cotangent is negative 3 over 2 equals cosecant squared alpha. Negative 3 over 2 becomes 9 over 4. It is positive because it is parentheses, which means I'm going to change the 1 to 4 over 4. That equals our cosecant squared alpha. That will give me 13 over 4 equals cosecant squared alpha. I will take the square root of both sides. If it helps you, when you take the square root of a fraction, you can immediately just write it as the top and bottom. You don't have to write it over the whole thing. If you know you're going to split it apart anyway, you might as well just do that. Now I'm going to attach a positive or a negative, but I'm going to make a decision right here. Do I want my cosecant to be positive or negative when I'm done? I want it to be negative because only cosine and secant are positive. So we're going to have a negative. So we're now going to have cosecant alpha equals a negative. I'll make that big, emphasize it, square root of 13 over 2. For sine alpha, leave the negative sign, bless you. we just flip the fraction and have 2 over square root of 13. So if you're on the test, I'm good with that. Just get it done, get it right. But just for the sake of class and maybe homeworks, remember that this is not simplified. So if asked to simplify, we have 2 square root of 13 over 13. So once again, I'll reiterate the fact that I don't think that simplifying these are important to me, but it might be important to you to check your answers. So if your answers look different, ask yourself, did I simplify it? Would I be okay telling Mr. Pabian that? Yeah. Am I okay checking the answer key? Probably not. Is that clear as mud? All right. All right, I covered one more topic on here, and it's a topic that I already covered on Monday. And these are the odd-even identities. And I see some people finishing up, so I'm going to go ahead and stop. We have the odd-even identities. Now, the reason why we have odd-even identities, if I ask you to simplify something, it means you cannot have negatives inside the parentheses. In other words, you can't have negative angles. So the odd-even identities are a way to get rid of the negatives that are inside of the function. So I told you on Monday, these are the ones that need to be memorized, because the other ones are all the same. So for cosine, if you have cosine of a negative angle, you can actually write it as just cosine of the positive angle. If I tell you find cosine of negative 30, you're going to say, meh, I'm just going to find cosine of 30 and we'll get the same thing out. Same thing for secant. Well, for sine, if I ask you for the sine of negative 30, you can find the sine of the sine of 30, but you need to attach that negative sign on the outside. So for all the rest of these, we have to bring the negative out front. And we did this on Monday, but now let's do it more concretely. I asked these same questions on Monday, and I'm going to ask them again. What is the sine of pi over 6? And don't just guess. If you have no idea, look at your unicircle. What is the sine of pi over 6? It is a positive 1/2. What is the sine of negative pi over 6? It is negative 1/2, which is the exact same thing as if I found the sine of pi over 6 and just attached a negative sign to it. So whether you find the sine of negative pi over 6 or you find the sine of pi over 6 and then put a negative up front, you'll get the exact same answer. For cosine, what's the cosine of pi over 6? Square root of 3 over 2. What is the cosine of negative pi over 6? It is still positive square root of 3 over 2. So anytime I would have asked this question on any previous test, if I asked you for the cosine of negative pi over 6, you could have just found the cosine of pi over 6 and you would have got the exact same answer. So whether it's a positive angle or a negative angle, you get the exact same answer out. Now, why is this important to us? I just mentioned it. When I ask you to simplify, you cannot have negative angles. So if I look at this first problem, the first thing I need to do is get rid of those negatives that are inside the sine and the cotangent. So you need to ask yourself the question, whenever you see something like this, can I just erase it because it's cosine or secant? Or do I have to pull it out front because it's sine, cosecant, tangent, or cotangent? So if I look at the first one, I have a sine. Sine says I can't just erase the negative, but I can bring it out front. Cotangent, just like sine, I can bring it out front. What happens if I have two negatives next to each other? They become positive. I'll actually write it out here. So this is the same thing as negative 1 times negative 1 times the sine of x, cotangent of x. A negative times a negative is a positive. So really I just have sine x times cotangent x. Now we go back to what we did for last night's or the other night's homework. And that is find anything that's not in terms of sine and cosine that looks like the cotangent and rewrite it in terms of cosine or sine. So my sine x remains. What do I change cotangent to? Cosine over sine. Thank you, people that are playing along. It'll make your life so much easier. And we're going to notice that sine x is really sine x over 1. Our sines cancel out, and we're just left with a positive cosine x, which seems a lot easier to deal with than sine of negative x times cotangent of negative x. That is fully simplified. There's no negatives inside. You can have negatives on the outside. You just can't have them on the inside. And we just turn everything that's not sines and cosines to sines and cosines. Questions? Except for going to the bathroom. Yeah.
Even with the two negative ones, where does that really go?
What's negative 1 times negative 1? Positive 1. So there really is a positive 1 here, if that helps you picture what happened to it, which is just positive. Because I don't usually write 1x, I write just x. In fact, most of the time I will not write this negative 1 times negative 1. We need to start realizing that if I pull out two negatives, it just becomes positive. All right, questions besides I need to go to the bathroom?
Just leave it like that?
Just, you're done. I don't think I could find a way to make cosine x any more simple than just cosine x. All right, then the rest of the time is